Dear friends, hearty welcome to the online problem solving session series organized by Maths Aspirants. Today, we are starting the JAM preparation series for the year 2027. We have started our group as a WhatsApp group in 2017, and from the COVID days, that means from 2020 onwards, we used to organize several online programs to help the students who are preparing for different national level competitive examinations and entrance exams. From today, we have a session focusing on IIT JAM 2027 examination, and we blessed to have Miss Diya Saha. She is from West Bengal with us to handle the session. Miss Diya Saha is an active member of Math Aspirants from her degree days onwards, and she did her MSc from IIT Bhubaneswar and currently working as a researcher at TCS and also a research scholar at IIT Kharagpur in the Department of Computer Science and Engineering. I'm sure that we have the best person to start our JAM preparation series. Ms. Diya cleared all these exams with a very good ranks, like exams like JAM examination, CSER, NET, GATE, and she's really a nice student. And I'm sure that she will discuss many preparation tips with you that will be very helpful to all those who are seriously preparing for this type of competitive examinations. I would like to thank Ms. Diya for being with Math Aspirants, and I welcome every participants, every member of Math Aspirants to this online problem solving session. I hope that this session will be really fruitful to all those who are seriously preparing for different examinations. Once again, I welcome you all. Welcome, Diya.
Thank you, sir. Thank you for this nice introduction. Good evening, everyone. Today, I will, as I said, I will share some preparation strategies, and I will explain the exam pattern, syllabus, and how to prepare for this type of competitive exams. And I will share some previous year questions and solving techniques for linear algebra, because it is a very important chapter in all the competitive exams, not only JAM, but also GATE, CSIR, NET, EIFR, ISI, you name it. They have linear algebra as a syllabus in the syllabus for those exams. And not only for maths, like if you want to appear in any other in the competitive exam for any other subject, like data science, now we have a paper in as mathematical statistics in JAM, and in GATE also we have a paper called DSA, that is data science and artificial intelligence. In all those exams, they have linear algebra as a main component of their syllabus. So I think we should learn it very carefully. So as I was explaining, IIT JAM, those who want to study in IITs after after our graduation, those who want to study masters in IITs, IIT JAM is a very important exam for them, and it is conducted by the 7 IITs, and sometimes the paper is prepared by IISc also, as in 2021 it was prepared by IISc. And It is a 3 hours examination and with total of 100 marks. And for mathematics, they have 3 sections, that is MCQ, MSQ, and NAT. MCQ is 1 correct option out of 4, and it has negative marking. And for MSQs, 1 or more correct options, there can be more than 1 correct options, and it the plus point is it has no negative marking. For numerical type of questions, you will not have any options there, but you have to calculate and write the correct answer as a fill in the blanks type of questions. We will see some of the examples. And the negative point is it is hard. I think it is harder than MCQ and MSQ because you have no options to eliminate some of the options. So you have to calculate it from scratch. And 10 to 12%, as when I was giving the exam, I calculated that 10 to 12% of your question paper will come from linear algebra. So it is a very important chapter in our examination. This is some important URLs. IIT JAM 2026 was organized by IIT Bombay. And this year, I think it is organized by IIT Madras, but the URL is not, the official website is not up yet. And this is the syllabus. You can go and check the syllabus there. And I think it has 3 sections. And linear algebra is one of the sections. You can check the eligibility criteria there also. It is always a good idea to check it, but I think if you have a graduation in mathematics, you can always go for it. If you are a final year student in your graduation program. And this is the most important thing. It has the previous year question papers there, and we should like, if you are preparing for any exam, you should always go through at least last 5-year question, because then you will get a clear idea that which type of questions are coming and all, and which type of questions are which sections are more important, because in the syllabus there are many topics are there, but some of them are more important than the other. So it is always a good idea to fast track which portion is more important, which portion needs your attention first. So this was the timeline for JAM 2026, and the timeline does not change much for each year. Like, it always follows almost this pattern. So you can expect that in 2027 also they are going to follow this pattern. So please keep track of the examinations. So this is a section, as I was saying, JAM 2027 has 3 sections. 2000, because it is it is 2026. For 2027 it is not up yet, but it does not change much. You can expect that this question structure is going to follow for 2027 also. For section A, you will have MCQ questions. It will have 30 questions, and in section A there will be 50 marks. For section B, you will have MSQ questions, which has more than 1 correct options, and there will be 10 questions, and you will get 20 marks there. And for section C, you have NAT type of questions, which you have to calculate from scratch. You will not have any options for those questions.
Hello.
Yes.
Hello, Dibaji. Hello.
Yes.
स्क्रीन में क्वेश्चन शो नहीं हो रहा है.
Sorry.
हेलो.
Yes.
स्क्रीन में क्वेश्चन शो नहीं हो रहा है.
You cannot see the slides.
Hello.
Yeah, there is no issue, Diya. You can continue.
Okay, okay.
Yeah.
Okay, thank you, sir.
Yeah, it's
Uh,
fine, Diya. Now you can hide that
okay,
button too. Yeah, everything is perfectly fine.
okay, thank you. So as I was explaining, for part A, there are MCQ type of questions. For you will have total 30 questions in part A, and 10 of them will be of marks 1, and you can score up to mark 10 marks here, but it has minus one third of negative marking for each wrong answer, and there will be no partial marking for any of the questions. And you will have 20 questions of 2 marks, and for 2 marks questions you will have, for each wrong answer you will have minus two-third of wrong negative marking. So we should answer part A very judiciously. We should not guess. And for part B, you will have multiple select questions, uh, and you don't have any negative marking here. But we should keep in mind, if you are not selecting every possible options, or if you are selecting by mistake a wrong option, you will not get marks for that question. So uh, part B, like for part B is easier than part A because you don't have any negative marking here, but you should also keep in mind that you have to select every possible correct answers. And for part C also, you will have 10 1 marks question and 10 2 marks question, uh, 10 2 marks questions, and you don't have any negative marking here. So, but you have to calculate everything from scratch. It is like fill in the blanks type of question. And for numerical answer, everything is. I am saying fill in the blanks, but the answer should be numerical time. That is why it is called numerical answer. Yeah, for in the JAM exam, you will have the virtual calculator, and you cannot carry your own calculator in the exam hall. So it is a good practice to like calculate everything, uh, up to which it is possible. You should practice to calculate the long calculations by hand, not use calculator. So, as I was saying, linear algebra is a highest leverage topic in every competitive exams which have in mathematics. And eigenvalue, rank nullity, diagonalization, these problems appear in almost every exam. So, uh, and it is a high scoring section of your syllabus. So you should focus on that. And was like I prepared these statistics when I was preparing for GEM. I thought that I should share it with you. I think some of the number distribution has changed, but not much. So as you can see, 16 of the marks is coming from linear algebra. So, and these are very important topics in your exam. So linear algebra vector, as I was saying, that if you open the JAM syllabus, we can also say that vector spaces, basis dimension, linear transformation, rank nullity theorem, system of equations, eigenvalues, eigenvectors. These are very important, and you should prepare for that. We will do some of the exams, some of the problems in today's class. Like we in today's class, we are going to solve problems from JAM 2025, and you can see that most of the questions from linear algebra is coming from linear transformation, basis dimension, and rank nullity theorem. So yeah, this is the most like 70% of the questions you can solve using these five theorems, but you should memorize the theorems, but when you are actually solving the problems, you will get a better hang of these theorems, because otherwise if the theorems and the problem, how to apply those theorems in your while doing problems will be two isolated topics, but we should not do that. We should first solve the questions, and we should judiciously solve the previous year questions, and uh, keep track on what kind of questions are repeating every year. And theory is, as I was saying, theory is necessary, but it is not sufficient. You should do exams. Sorry, you should do you should practice the problems, and you should give as much mock exams possible. As much mock exams possible. I know, sir, organized every Saturday or every Friday, sir, organize a mock exam. You should always participate on that. And before in JAM, when IIT Madras published their official JAM website, before exam they publish one or two mock exams. You should definitely participate on that. It will give you environment, about online environment, where you can test how ready are you to go to sit in the online competitive exam, because in the exam center you have to give your exam in a computer desktop. So you should keep your practice in that. And I used to give some previous year questions as exam. Like I will set a timer of 3 hours, and I will solve the questions as much as possible, and I will grade the papers using the answer keys, and test how much I am scoring there. So it is also a good idea to do that. So yeah, I think we should go for a problem solving session now. Okay. Sorry, the answer is visible. Okay. Let me just stop the screen. So is my screen visible?
Yes, ma'am.
Okay. So Do you know how to calculate the rank of a matrix?
Yes, ma'am.
Okay. So can you please, I am giving you the question. Can you please calculate the rank of this matrix?
Ma'am, is it 2?
Yes. So how do you calculate the rank of a matrix? Like we do row deduction and we calculate the simplified form of this matrix. And so here we have two non-zero rows for this matrix. So this is just wait for a moment. I will share the question paper GEM 2025 question paper with you. Then we will solve some of the problems from there. Okay, so we will solve GEM 2025 question paper here. Uh, as I was saying, that question 6 is a linear transformation question, and we will start solving the paper. First, I want to know that uh, do you know what is a linear transformation? Linear transformation is a function. Say T is a linear transformation.
Ma'am, is
And
it like it satisfies two properties T of x plus
yes,
y
yes,
is
yes. T is defined from U to V, where U and V are vector spaces.
It is just like homomorphism between two vector spaces.
Yes. And if U1 and U2 belongs to U, then T of U1 plus U2 should be T of U1 plus T of U2. And if A is a scalar, then T of A is U belongs is A of T U. And what is rank nullity theorem?
Dimension of range plus dimension of kernel is equals to dimension of domain.
But for in this case, what should be the if I want to write the rank nullity theorem in using T and UV?
Rank T plus nullity T is equal to dim B. Dim U, sorry.
Right. So, as you all are aware of this, uh, can you try to solve this question 6? Please let me know. Uh, any of you have done. I am going to solve it, but I think you should try it first. So, are all of you aware, like when we are saying a function t as 1 or on 2?
Yes.
Okay.
Ma'am, is it D option? Like it is not 1 and not onto.
Yes, it is D. Okay, I will start solving it. So for R3, we have a basis that is and dimension of R3 is 3. So we will see what is the image of T for these basis vectors. Now we have the image, and we can also write it as a linear combination of our basis vectors, because here T is from R3 to R3. So if we write the matrix, it will be now if we when we try to find the rank of this matrix, it will become now we can see this see that our row 3 and row 2 are linearly dependent, and if we simplify it, we will get so as rank of this matrix is less than 3, it is not like it is not 1 1, and from the rank nullity theorem we can say the no, sorry, as rank is less than 3, it is on 2, it is not on 2, and when we use the rank nullity theorem, it is also not 1 1, because current dimension of kernel T will not be 0. So there is like there is one x not 0 such that T of x is 0. So T is neither 1 1 nor 1. So our option D is correct. So this question 7 is also from linear algebra. Um, can you try to solve it? Do any of you have any queries on question 6?
No, ma'am.
Okay, thank you. Please, can you try question 7? Okay, I will start solving. So m is given as 2, 0, minus 1, 4, 1, minus 2, 2, 0, and x. Now we have 0 as the eigenvalue of m. Now zero, and they want you to calculate now if we have m, if m has and 0 eigenvalue, what should be the determinant of m?
0.
Right. Why the determinant of m is 0? Because the determinant of m is multiplication of the eigenvalues of m. So I am writing 3 eigenvalues because we have 3 by 3 matrix here. So our determinant is 0. And can you say that what will be the trace of m?
Sum of the eigenvalues.
Right.
Some of the diagonals.
Sum
the
of the
diagonal.
eigenvalues. Yes. So now we have 0 as a eigenvalue. So we know that determinant of m should be 0. So we should try to find, and we need to find what is x first. Otherwise, we cannot calculate this. So if we calculate the determinant of m, it will be now we know that determinant of m is 0. So x is minus 1. Right? Right?
Yes, ma'am.
Yes. So, and we also know that trace of m is sum of the eigenvalues. Now our m becomes and we know how to calculate the eigenvalues of it, right? We should first calculate this. Now this 2 has 0. So we should simplify the matrix from, we should simplify the determinant from this, uh, from the here. So it will be So 0 is one eigenvalue vector and 1 is another eigenvalue of M. So our given vector is 1, 0, 1. Now say V is the corresponding value of lambda. Then what is the corresponding eigenvalue of M to the power 5 or M to the power 4?
Lambda raised to 5v.
Right. Lambda to the power 5 is the corresponding is an eigenvalue vector of M to the power 5. Similarly, lambda to the power 4 is also an eigenvalue for M to the power 4. Now, our M is now say our V is 1, 0, 1. Sorry. Can you calculate what will be the answer?
is the column with the 101.
Right. So 101 is eigen vector of M for lambda equal to 1. Right. Then MV is equal to V. Now M to the power 4, right? For the here we have to calculate M to the power 4 plus M. M to the power 4 V will be also V because our lambda is 1. So lambda to the power 4 is also 1. Right?
Yes, ma'am.
Okay.
Yes.
So M to the power 4 plus MV will be M to the power 4V plus MV will be V plus V. That is 2V. So our answer is 202. So option B is correct answer. Did anyone get option B?
Yes,
Or
ma'am.
do you? Oh, okay. Do any of you have any doubt? Please let me know. Otherwise, we'll go to the next question. Okay. Please let me know if any of you have any problem. This is the next question. Question number 8. This is almost similar to our first question that we have solved, question number 6. First, please try to form the matrix representation of T as I have done in question 6. So, do you know what P2R signifies? In the question, they have said that P2R and 1x square is the ordered basis of P2R. Do you know what is P2R?
Set up for polynomial of degree less than
Polynomial of grade 2.
Yes, polynomial space of
degree.
form. Yes, up to degree 2. So, this is the basis of P2R, right? If I say P3R, then our basis will be 1x square up to x cube. So dimension of this P2R is 3. And here the dimension is 4. So let's say we put T of 1 here. That is Px equal to 1 for all x belongs to R. Then according to the definition, our this will Px goes to Px plus 1. But here Px is 1 for all x belongs to R. So this should be 1, right? Do any of you have any doubt in this? Please let me know.
Amen.
Okay. So now if we say T of x means here x means P of x is x for all x belongs to R. Now if we use the T operator here, it should go to P of x plus 1. So T of x will go to x plus 1. Right. Now as this is an ordered basis, I will write it as T1 plus x. Similarly, if we use P of x square here, then is x plus 1 whole square. Then if we write it like this square, then so our T of 1 is 1, T of x is 1 plus x, and T of x square is 1 plus 2x plus x square. So when we write the matrix representation, what should it be? Zero, zero, 1, 1, 0, 1, 1. Now we have to check if this is correct or not. we have to we need to check determinant, rank, eigenvalue, and nullity.
Ma'am, only option C is correct.
Right. Determinant is not 2 because we can clearly see it is 1. Rank of m is 3. Eigenvalue is if we did m minus lambda I, we will get 1 as the eigenvalue. 1 is the eigenvalues here. And nullity as 3, rank of m is 3. Nullity is 0 from the rank nullity theorem. Nullity is 0. So only our option C is correct. So is it clear? Is question 8 is clear?
Yes, ma'am.
Yes.
So now we will go to these the all the previous ones were marks 1 questions. From here on we will start marks 2 questions. Question 15. So, do you know when the system S has a solution? Like if we write the system S as mx equal to b, where x is so x2, x3, x4, b is 8, 16, and 32. So first tell me, like if I write it as like this, so what should be these dimensions? M is from R4 to R3, right?
R3.
Right. And do you know when it has a solution? Do you know something called augmented matrix?
Yes, ma'am.
So rank to have a solution, rank of M should be equal to rank of M by B, right? This is the
Yes.
augmented matrix. But first try to find out what is the rank of M. I will give some hint because uh, like as you can see in the question, the first statement is what is the rank of M. So you can like negate at least two options from here. So now, uh, can you give any insights from this
Rank is 3.
rank history? Why?
Ma'am, there are 3 non-zero rows.
Yes, there are no, not three non-zero rows. These three rows are not dependent of each other. You cannot write this any of these three rows as a linear combination of the other two, right?
Yes, yes.
Yes. So ideally, you should uh, like go to the row reduced form of the matrix. But as we are writing a competitive exam and time is very important here, and you can see from here that it is not dependent to each other. So we can say that the rank of this matrix M is 3, right? So option C and D is not true. So op- our correct option is among option A and B, right? Now
Yes, ma'am.
we have, now can you calculate the augmented rank matrix? The rank of the augmented matrix?
Ma'am, that is also 3.
That is also 3. So uh,
So it has a
option,
solution.
it has a solution. Option A is correct. So do others have any issues with this problem? Please let me know in the comment section, or you can unmute yourself and okay. Okay. Thanks, Diyat. Let's proceed to the next question. That is option 16. Yeah, it is almost like it is. It also has, you have to calculate the HCT. The eigenvalues are given, so you can say it is almost similar to question 7. Can you please try it first? See, there they have given m cube v is 5 cube v, but can we say that 5 is an eigenvalue of m? We have to check that. My suggestion is plus first try to calculate what is x. Then, like previous question, you can automatically discard two options.
Ma'am, in previous sum, it had 0, so we were able to calculate it properly. Here, the third eigenvalue is also missing, and the determinant x value also we have to find.
Yeah, then what should we do? Let's see. So our m is right. So if you calculate the trace of m, it will be 8. And if you calculate the determinant of m, that is can you say what will be the determinant of it in here? This, right?
Yes, ma'am.
Shivakant is saying option B is correct. Let's see. Let's see what happens. Indumati is saying option A. Let's solve. Let's solve because we have two conflicting answers. Now lambda 1 is 2 and lambda 2 is 3. These are given. We know this. So let's say lambda 3 is k. So let's number these equations. From option equation 1, what do we get?
2
Trace?
plus 3 plus k is equals to x.
Yes. 2 plus 3 plus k. I do, sorry, lambda 2 is minus 2. So minus 2 plus 3k is equal to x. So k plus 1 is equal to x and k is x minus 1. Let's say 3. From 2, we get minus 2 into 3 into k is equal to minus 2 plus 2x plus 3. So 3k is equal to 2x plus 3. Now if we put k is equal to x minus 1, simplify it, what will we get? X is equal to 6, right?
Yes, ma'am.
So our option A and C is not true. X is not equal to 5. X is not equal to 5. X is equal to 6. Now our next question is if m, these are two separate questions. Okay. M cube is 0. Now we have our m, right? M is minus 2, 0, 0, 3, 2, 3, 4, minus 1, 6. M of 0, 1, 1. What will we get? Let's multiply. So 5 is an eigenvalue of m, right? Okay. So m cube and like this, right? So this hypothesis is true. M cube, this is true. Right?
Yes, ma'am.
So now our eigenvalues of M are -2, 3, and 5. And we have to check if M square plus M is invertible or not. Now, for M square plus M, what will be our eigenvalues? -2 square plus 2, -2, that is minus, that is 2. 3 square plus 3, borrow, sorry, 12. And 5 square plus 5. So none of them are going to 0. So our determinant of M square plus M, if we call it as A, so determinant of A will be non-zero. So M square plus M is invertible. So our option B is correct. Indumati, she said that was saying that option A is correct. Now, is it clear why option B is correct? Option A is not true because X is the first part of the statement is false because uh, X is not equal to 5. X is 6. So both part of your option should be correct. You have to be very careful while choosing the answer. So is question 16 clear for all of you?
Yes, ma'am.
Okay. Okay. Let's solve this question. This is a very interesting question.
Daddy में का
Ma'am, is this question a multiple select question?
Is this question a multiple choice question? Let me see.
थोड़ा मारा टिप्पण बोला
No, it is only one option correct.
Okay, ma'am.
I think someone asked why invertible. Is it about the previous question?
yes yes
Okay. So here you are asking why m square plus m is invertible, right?
yeah
So we got the eigenvalues of m as -2, 3, and 5, right? So
right
now what will be the m square plus m in if as I was saying earlier that if lambda is a eigenvalue of m, then lambda square is an eigenvalue of m square. Mv is equal to lambda v, right? Then m square v is m of mv, then it is lambda v. Now lambda is a scalar, then it will become lambda of mv, then it is lambda v again, it is lambda v, it is lambda square v. M square v is lambda square v. So lambda square is eigenvalue of m square. Is it clear? So in this formula, when we are calculating the eigenvalues of m square plus m, all the eigenvalues are non-zero. None of them are equal to 0. All of them are non-zero. So determinant of m square plus m is non-zero. So this is non-zero eigen. So it is inverted. Okay. So one of you have given an answer. That's I'm going to solve it. Fi is going from R4 to R. So if you use rank nullity theorem, then rank of Fi plus dimension of kernel of Fi will be 4. So dimension of kernel of Fi is equal to 3 because rank of Fi is 1 because this non-zero linear transformation and it is going to R. So the dimension of rank of Fi can be 1 or 0, but as it is saying it is Fi is a non-zero linear transformation, rank of Fi will be 1. So now we have also in the question it was given that kernel of F1 is F2 intersection kernel of F3, and now nullity of T is dimension of kernel of T, and kernel of T means T of V is equal to 0, right? So if 1 V, if 2 V, if 3 V is 0, 0, 0. So V belongs to kernel of F1, Fi, V. No, or we can write it like that. Kernel of F1V intersection of kernel of F2V intersection of kernel of F3V. V should belong to kernel of all Fi's. So, and we know that kernel of F1 is subset of kernel of F2 intersection of kernel of F3. Now, so if V belongs to kernel of F1, then this satisfies, and we have calculated that kernel of F dimension of kernel of Fy is 3 for all I. So dimension of T is 3. Oh, sorry. So our correct option is 3. So as it is 8:35 already, I will go to a NAT type of questions. As I was saying that I will give you an example of NAT type of question. Let's see question 46. So we have already solved this type of question. Can you guys try? So NAT type of, as you can see in NAT of type of question, there is no options given. You have to solve it by your own. You cannot discard 2 or 3 options as we were doing for some of the questions. What does it mean by if x, y, z, w belongs to V1 intersection V2 intersection V3? Can anyone answer? Or do you know what does it mean by if x, y, z, w belongs to V1 intersection V2 intersection V3?
The element belongs to all the three subspaces.
Sorry?
And the coordinate that XYZ that belongs to all the three subspaces.
Yes, all three subspaces. But here, what does it mean? It should satisfy all these three equations, right?
Yes, ma'am.
So, so if we write it in a matrix format, like mx equal to b, what will be our m? Now, if you like, you need to find out what is the dimension of the subspace V1 intersection V2 intersection V3, right? So, if by the rank nullity theorem, what will we will get? Right? So you need to find the dimension of M. You need to find the rank of this matrix. You need to find the rank of this matrix. Then you will get the dimension of this space. That is your answer, right?
Yes, ma'am.
So what is the rank of M?
2, ma'am.
Right? Rank of M is 2. If you do the row reduced form, you will get that rank of M is 2. So from the rank nullity theorem, our dimension of this V1 intersection V2 intersection V3 is 4 minus 2, that is 2. So I think we have reached almost at the end of the session. It is 8:45 now.
Yeah. Okay. Yeah, Hello.
Yes, sir.
Yeah, please turn on the video. We can go for the, yeah, right. Thank you, Diya, for this nice session. And dear participants, it is now your time to share the feedback, share your comments. So please feel free to share your comments about the session. And if you have any query regarding the topic that we discussed or anything about JAM examination, that also you can ask now. Yes. Yeah, Jivita. Hello. Hello, participants. Yeah, right.
So sorry, sir. I got etc. So should I give my introduction also?
Yeah, please keep the
So
video on if possible.
wait.
Yeah, right.
Correct. So, hello everyone. My name is 𝔸𝕬𝕦 and I am from St. Xavier's College pursuing TY BSc Mathematics. First of all, to begin with my feedback, I would like to sincerely thank Vinod sir for organizing such a wonderful and interactive sessions for students who are preparing for IIT JAM examination. Really, these sessions are truly helpful and motivating for aspiring mathematics students. I would also like to express my heartfelt gratitude to Diya ma'am, who really took out her time to teach us and to guide us today. And the session was extremely informative, well structured, and engaged. I really liked the way how ma'am explained all the topics which was important for us for the examination. I really loved, like, now I understood in which all part I have to put the extra efforts, like which all topics are really important for linear algebra, but not to understand, like not to put much all efforts in other parts which are not much necessary and all. And the explanations were very clear, and the selected problems which she has done today for IIT JAM 2025, which was really helpful for us. Overall, it was a lovely and enriching session, and I genuinely loved and enjoyed learning from it. Thank you once again to Vinod sir and Diya ma'am for your guidance and support. Thank you, ma'am.
Thank you, Jivita.
Thank you, Jivita. Thank you for your kind words.
Yeah, other members, feel free to share your feedback. It's really very nice to hear from the participants. So I request other participants to come forward. Yeah, Shivakant. Yeah, Alagananda, you can speak.
Hello, ma'am. Hello, sir.
Yes, Alagananda, you can speak now.
Hello, sir. Hello, ma'am. I'm Anagananda. I just completed my BSc. Today's session is very helpful. You answer all. You detailed. You. Thank you, ma'am, for the session.
Okay, thank you, Alagananda.
Thank you, Anagananda.
So I request other members to come forward and share your feedback. I have seen many members are actively involving in the discussions. So Srilaya has written the comment in the chat. Diya, you can have a look at that. Many people are giving their feedback in the chat.
Sure.
Yeah. So I request members to share the feedback in the live session itself. If possible, keep the video and audio on and express your, that will be very nice. If you have any specific doubts regarding IIT admissions or preparations, that also you can ask now. So feel free to make use of this opportunity. We are having our Diya with us.
Ma'am, I had a doubt like regarding if I'm applying for this IIT JAM 2027 exam, and if in case if I'm not getting applied into it, and I'm interested in pure mathematics much. So any other colleges apart from IIT would you recommend?
Any other colleges, like you can always, you should look into TIFR and ISI. Like these are very good institutes, like one of the best in, if not the best institute in India to pursue pure maths there. And you can also give CUET. There are many good state colleges. You should definitely look into that. And those especially for CUET, the syllabus is almost same as JAM.
Okay, ma'am. Sure. Thank you so much, ma'am.
Yeah, Jivita, there are many other exams other than JAM also, and the preparation will be useful for all that.
Yes, sir. Thank you so much, sir.
JAM will be the first exam. Yeah, of course, TIFR exam will be in December, and then JAM examination will be in February, and almost other examinations will be in May.
Okay, sir.
Comparatively, the most important thing is that comparatively the easiest syllabus is for the JAM examination.
Yes. TIFR and ISIs are
more tough. And also one thing, in that exams there will be an interview also after the exam. But for JAM, if you have a good rank, then you will directly get admission to IITs and NITs without any further interviews.
Okay, sir. Understood. Thank you so much, sir and ma'am.
Yeah, thank you, Jivita.
Excuse me, sir.
Yeah, right.
Hi, sir. I'm a PG student, final year student, sir. I'm pure maths PG student, and I'm willing to write NET examination. Can you explain or help us where I can get coaching for that, sir?
Yeah, Diya, you can share some of your insights about the NET examination.
Yeah, for NET examination, it is like 70% of the syllabus is almost same like JAM, like linear algebra, real analysis, OD, PD. Those things are similar like JAM, but you will have some extra new chapters there, like complex analysis. I think for ring theory, those will also come. Like for JAM in abstract algebra, you will only get the group theory part, but for NET, you will have to do the ring theory and I think the field theory. Those things will come. So you should prepare for that. And but the question level is for NET examination specifically. The question level is almost similar like GATE exam. So if you solve those PYQs, you will get a good idea about the difficulty of the exam.
Okay, ma'am. Thank you so much.
Yeah, Madhumitra, the only difference is that there will be more advanced topics for NET examination. Practicing the questions that that are PYQs of JAM examination will definitely be very helpful for your NET preparation as well.
Thank you, sir. Thank you, ma'am. And your teaching was really good, ma'am.
So, Madhumitra, where are you from, and where are you studying MSc?
I am from Coimbatore, sir. I'm studying in MSc in Dr. NGP Arts and Science College.
Okay.
And I have another question, sir. Where I can follow you again, sir?
Sorry?
Where I can follow you, sir? Like I got it from a general group.
Yeah, I have shared my WhatsApp number in the chat. You can message me. You can join our WhatsApp group. It is a discussion platform. You can share your doubts there. and you will get information regarding the different examinations and admission procedures in that group. That will be helpful. So message me in WhatsApp, that the number that I have shared in the chat.
Okay, sir. Thank you so much, sir.
Any others? Yeah, Karthi is shared about job opportunities after MSc in IITs. Yeah, of course, almost all the IITs are offering placements after MSc. Yeah, actually, I think, yeah, Diya, if you want, if you wish, you can add something regarding
Yeah,
the.
actually, I myself uh, got my job in TCS research from the campus placement in IIT Bhubaneswar. And you after joining IIT course, you need to maintain a good CGPA. I think 8 is the average. You should keep a good CGPA, and in different IITs, they have different criteria for that. In our IIT, it was 8. So you should keep maintain the good CGPA, good academic record, and you should do internships in summer internships or winter internships. Many IITs now offer internships for math students. So when you do the internships, you will get more visibility, more ideas about what to do, or you will have experience in working some projects, in research projects. Many R&D institutes, they look for this type of qualities from the math students. If they are recruiting a math students, they expect that they have some ideas about how to work in a project, how to do logical things and all. And um, if if you are interested, you can look in the applied part of the maths, like neural networks. Nowadays there are many branches are there, like data science. You can go and look into that, and you can build your profile in that. Like in IITs, they also offer some elective courses. So in our IIT, they used to offer elective course in neural networks. So I chose that, and I got, I learned so many machine learning, many basics of machine learning from there. And those questions generally come in the when you are sitting in a placement, they will ask those questions in your interview.
Yeah. Yeah, let me add something. See, why the one of the other advantage of studying in a premier institute is that you will get more contacts with the academic circles. You will get contacts with many professors from different premier institutes. All that will be helpful if you want to pursue PhD or some other research projects and all that. So getting an admission in an IIT will definitely change your future life in a very significant manner. So it is your time to take all your effort to clear the JAM examination and get an admission to your dream institute. That will be really a turning point in your life. Okay, so many of the participants shared their feedback in the chat. Shiva, 𝔻𝕨, Srilaya, Indumati, Kubai, Amrita Bhattacharji, and Shivakandocha and Karthi. Thank you for your feedbacks. And I request all the participants to seriously attend our online problem solving sessions. Active participation is a must from your side. Then only we can arrange such sessions. I request all of you to actively participate in the future sessions as well, and also welcome your friends and your classmates to our group and for this type of sessions. We will try to, as it is the first session of the next IIT JAM examination, definitely we will try to arrange more such sessions. So be actively involved in the discussions in the group and attend this type of sessions. That will be really a great motivation for me and others to organize this type of programs. Once again, I would like to thank Ms. Diya for being with Math Aspirants, and also as she's doing the PhD now, I would like to express my heartfelt wishes and blessings for a great academic future. Thank you, Diya, for being with Math Aspirants.
Thank you, sir. It's a great honor. Actually, I used to participate, that I used to participate in many of the sessions almost regularly as much as I can. And now I am organizing a session. I am discussing the previous year questions. So this is.
Yeah, from the degree days onwards until up to MSc, before joining the job and all that, Diya was a very active participant in all the sessions, and she used to come and ask questions and share feedback in almost all the sessions. If you check the recorded videos of our previous lectures of that time, you will see Diya there in that lectures.
Yes, it's almost like
it's a great privilege for me to have you as a resource person. I think this is the third session Diya is taking in our platform. All the previous sessions are available in that YouTube channel of our Bijumon sir. All the recorded videos are available there. You can make use of, all the participants are advised to make use of that sessions. And I take this opportunity to wish all the participants a great success in the forthcoming examinations, and I request all the participants to attend our future sessions. And once again, I thank Diya and other participants for being with us. Okay, thank you.
So, before to end, I also wanted to thank you for informing us in that group. Through that group, I came to know about the swim summer camp in which I participated this year. It was a wonderful experience which I got, and it helped me really to build my mathematics foundation really better than which used to I have. So I'm really grateful to sir for his constant support and guidance, and I hope so, sir, you will be continuing doing this. It is really helpful for the other students also.
Yeah, definitely. I will try to organize this type of sessions in future as well. But one request from my side is that be active in the group and this type of sessions, and also help me to reach more students. So please convey with your friends and classmates about this group and guide them to join our group. Remember that our group is a purely voluntary one, and anyone who wish to pursue maths seriously, I think our group will be definitely will help in some sense, at least in some sense. So once again, thank you everyone. Let us wind up here. Thank you.
Thank you.
Thank you, Diya.